Hi chemistry students. So I just wanted to do a couple of example problems that you'll be seeing on the upcoming test. So the first one I'm going to do tonight is a stoichiometry problem, a limiting reactant. I know some of you guys have had difficulty with these, so let's have a look at one. And this is question 38 from the chapter review of stoichiometry. And it says that if we have zinc and 2 HCl, that will form zinc chloride and hydrogen gas. Okay, and it gives us the mass of zinc chloride is 5 grams, and it doesn't actually tell us the mass of the HCl, but it tells us that we have 100 mil, so our volume is 100 mil, and our concentration is 1 mole, so a molarity of 1 moles per litre. And it wants to know the mass of the zinc chloride and the mass of the hydrogen gas produced. Okay, so we need to figure out which of our reactants is limiting. So in order to do that, we need to figure out how many moles of each we have. So let's look at the first one. Zinc, we have 5 grams, so hopefully by now we know how to do the moles of this. N equals M over M. We have 5 grams, and zinc, the molar mass, is about 65. So our N will be 0.077 mole. Okay, so we've got about 0.077 mole of zinc. Now, for our hydrochloric acid, we know our volume is 100 ml and our concentration is 1 mole, but we don't know the mass, so we can't use the previous equation. What we need to do is use this one, C equals N over V, or if we rearrange it, N equals CV. Our concentration is 1 and our volume is 0.1, so 100 mils is 0.1 litres. Multiply those together and we have 0.1 mole of HCl. Okay, now we could look at this and say, right, zinc, we've got 0.077 mole, hydrochloric acid, we've got 0.1 mole, zinc smaller, that'll run out first. Not necessarily, because of the ratios. So if we have a look at the coefficients, up the top, for every 1 zinc, we need 2 hydrochloric acids. So we only have this many mole of zinc, and we have this many mole of hydrochloric acid. So because of this ratio, because we need 2 hydrochloric acids for every 1 zinc, and we have 0.1 mole of hydrochloric acid, the hydrochloric acid will run out when half of this amount of zinc is used. Okay, 2-to-1 ratio, so we need twice as much as we have zinc. So the hydrochloric acid will run out when we have used 0.05 mole of zinc. And so you can see we have more than 0.05 mole of zinc. All right, so we know that the hydrochloric acid is our limiting reagent. All right, the hydrochloric acid will run out first because there is less than twice the amount of zinc. Okay, and we need there to be twice the amount for them to run out at the same time. So our hydrochloric acid is our limiting reagent. From here, it's not too difficult to figure out what to do. So let's look first at our mass of zinc chloride. So the number of moles we can make of this. Have a look at our ratios again. For every 2 mole of hydrochloric acid, we can only make 1 mole of zinc chloride. Okay? So, again, we can only make half as much zinc chloride as we have hydrochloric acid. So the moles is going to be 0.05. Okay? Now, so that's the ratio. 2-to-1, we can only have half as much zinc chloride as we have hydrochloric acid. Okay. So, now we know the number of moles, we know the mass, well, we know the molar mass of zinc chloride. The molar mass, if you add it up, zinc is about 65, 2 chlorines is about 71, so the molar mass will be about 136. Now, our actual mass is equal to 0. Oh, that's very messy. Our actual mass is equal to 0.05 multiplied by 136. So our actual mass is going to be 6.8 grams. Okay, we've got 6.8 grams of zinc chloride. Now again, the hydrogen gas. Okay, so let's do that one over here. Now our number of moles, again, is going to be 0.05. There is a 1:2 ratio between the hydrochloric acid and the hydrogen gas. So we need 2 HCl's to make 1 H2. So therefore, we can only make half as much hydrogen gas as we have hydrochloric acid. So our number of moles is half the number of moles of the HCl. So N is 0.05. Our molar mass of hydrogen is just 2. Okay? Because, 2 hydrogens in a hydrogen molecule, so it's a mass of 2. So therefore, our actual mass is equal to 0.05 times 2, which is equal to 0.1 grams. Okay, so there we go. There are our answers. We have 6.8 grams of zinc chloride and 0.1 gram of hydrogen gas. The hardest part in this sort of problem is knowing how to apply the ratios with the coefficients. Okay, if you can figure that out, if you can figure how many moles of each thing you're going to create, the rest of it's pretty easy.